Awesome. There we go. Alrighty. So everyone, howdy. Welcome to week 2, day 1. So again, last week, you guys learned how to use Git and GitHub tools. You messed around a little bit with ChatGPT for prompt engineering, and got back into the flow of things with Python and JavaScript. So today's lesson is just gonna keep adding to your toolkit. And we're going to just work on some hopefully relatively simple concepts that can be extremely powerful. And that's basically going to be looping. So we'll just do it in Python. So loops. Can anyone tell me what a loop is, like broadly speaking?
Code that
A
repeats.
Okay, yeah. So it's basically just like something that happens over and over again, right? So what's a good example of a loop? Like a daily commute is a decent example of a loop because you're literally going from point A to point B and then back to point A and then back to point B, and you keep on doing that. Or in the same way, you could also have a loop be something like a counter, which is one of the simplest examples of loops that we use all the time. So, let's say that I want to print the numbers from 1 to 10. So the easy way to do that is just going to be print 1, print 2, print 3. I could keep doing that. But let's be honest, I'm gonna end up typing like 10 lines to print the numbers 1 through 10. That's not great. And also, what if I wanted to print the numbers 1 through 175? Then I'd have to end up writing 175 separate lines. That sounds absolutely terrible. So let's see if we can come up with a slightly easier way to do this. And this is where our loops can come in handy. So we have two types of loops that we can use. So we have a for loop and we have a while loop. How many of you guys have dealt with for loops before? Okay, cool. So would somebody mind telling me, just like in general, what is a for loop? Like, what's
for
the
loop
structure?
for a given condition, repeat.
Yeah. Or like more generally for the for loop, it's more like for each element in a thing, and then we're gonna repeat over it. So, if we have like an array, let's say like we have or like we call it a list, um let list 1 equal list of things, then if we wanted to iterate over that list, we can say like for item in list 1 and then do stuff. So that's the gist of a for loop. It's really good at iterating. So iterating or going item by item through a list and doing stuff with it. So the while loop is conditionally based. So while loop looks like while condition is true, then you're just going to do stuff. So runs conditionally, only runs as long as a statement is true. Or here, let's say runs repeatedly as long as a statement is true. So let's see some examples. So first of all, let's do it with the numbers 1, or here, let's just make an array. So or a list. So let's say nums 1 to 10. And here, let me just make that a little better. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how can I write a for loop that will go through this list and print out every single number in it?
Uh, just for nums.
or for num in nums 1 to 10,
All right. And then
and
what
then
would we do next?
print num.
Sure. So let's see if that will work. So let's save it. Oh, that's funny. All right, okay, let's try that. And let's hit run in the terminal. And ta-da, we see that it does indeed print out the numbers 1 through 10. So how does this work? Well, the first thing it'll do is it'll read in that list and it'll say, all right, I'm going to declare a variable called num that essentially is like a little arrow or a pointer, if you will. So first num is going to point to whatever lives here, which is the number 1, and it'll print that. Then it's done with that code, so it's going to move num from here up to here. And then it's going to say, okay, num is now 2, so we'll print 2. And then it'll go to the next item, and the next item, and the next item. And we'll keep doing that. So that's great. But this is, this is a very generic list. Like I can technically like replace half of this stuff with like banana. We can make this like false. We can capital, and we can make this like, a decimal. And the same thing would still run because it's generic code for our purposes. So, how can we change it so that it only, well, or to back up. So the for loop will work regardless of what iterable or array-like structure we put in. So you can do this over arrays, you can do it over tuples, you can do it over enums. We'll get into that a little bit more later. But the simple option for us that we're going to talk about right now is just iterating over a regular list. So we saw it with a list that's just numbers, it can do that. It's a list here with mixed data types, right? So we have a string, we've got an integer, we've got a Boolean, we've got a float, and it successfully iterates over all of them, which is great. So the other thing that's important to do is know how to iterate over ranges. So let's say that we want to iterate over that, again, 1 to 10 number range. So we can just do that dynamically using this range function. And as you can see in this handy dandy note that, VS Code was giving it to us. There we go. Okay, wait, let me move this. Perfect. So the range function will produce, as it says, a sequence of integers from the start, which is usually 0, up to basically the stop minus 1. And the range function only does this for integers. That is something very important to know. So if we wanted to do this from 0 to 10, you might think, oh, we'll just do range 10. But if we run this, where's the run button? There it is. We'll see here that it starts at 0 and ends at 9. But didn't we just say that the range is 10, so shouldn't it go from 1 to 10? Problem, again, is that the range function will start at 0 and end at whatever you input minus 1. So if you want to do a range from 1 to 10, what would you have to put for the start and stop?
11.
So we'll put 11 for the stop, and then what would the start need to be?
1.
1.
Yeah. So let's just hit run again just to make sure. And we see here that indeed it starts at 1, right? It starts at 1 and then goes up to 11 minus 1, which is 10. Perfect. So there's some other handy things we can do. So we can say we have a start, we have a stop, and then we have a step. So the step can basically be how much we're going to skip. So let's say that we wanted to only print out the odd numbers between 1 and 10. So there's 2 ways that we can do this, right? One, how can we check if a number is odd?
Use a modulus or
All right.
module.
So how can we do that, Vincent?
So you check if there's a remainder if you divide it by, or the modulus of 2.
Okay, so we'll say if the num mod 1, num mod 2 is 1, print it. and then else, we just don't have an else because we don't want it to do anything. So this should hypothetically print 1, and then 3, and then 5, and then 7, and then 9, and stop there. So let's check that that works. It does. Perfect. But note that this loop here is still going through all the numbers from 1 through 10, right? It doesn't necessarily skip the even numbers, which is what we'd like it to do. So let's take out that if statement and let's look back at our range to see if there's any way that we can skip numbers. And that's where the step can come in. So if we say that we're going to go with a start of 1, a stop of 11, but a step of 2, and we run it, we'll see here that it just basically says 1, and then 1 plus 2 is 3, and 3 plus 2 is 5, etc. So sure, at the end of the day, both approaches, whether with using our if statement or using our stop, give us the exact same result. But the difference is that the approach with the if statement still ended up with num going through all the numbers from 1 to 10. But with the step, we essentially were able to skip every even number. Does that make sense? Any questions about that or about the for loop?
Got a quick question on the concept. Since we're actually literally skipping it when we do the range with the steps, is that more efficient from a processing standpoint, like in the long term?
I would say so. I mean, if you have like, let's say that you're iterating over the range 1 to 1,000,000, then you're going to be running that loop 1,000,000 times. And if you only want to ever do stuff with the odd integers in that, you're still going to be running it 1,000,000 times, even though you only have 500,000 odd integers. However, by using by using the step, you're only looking at the part of the range that you're really interested in, and that cuts down the number of times you loop by half. We will go over something in a few weeks called Big O notation, which is all about optimizing your algorithms, which is something that gets really important, especially when we're dealing with big data sets, which we'll get to later. But in general, the fewer number of times you run through a loop, the better. But at the same time, if your loop saves you from writing out the same command like 15 times, please use the loop. Don't write it by hand. The other reason that we like using loops as well is we can keep our loops relatively flexible, right? So for example, previously when we wanted to write the numbers from 1 through 10, we had to say print 1, print 2, print 3, print 10. Well, now we can just use range to say I want to print the numbers in the range 1 and then 11, which is 10 plus 1. Now, let's say that I wanted to get all the numbers between 1 and 1,500. Well, all we need to do is change this 10 to a 1,500, and bam, you've got all the numbers from 1 to 1,500. Pretty simple. So another benefit of loops is you're able to keep them more flexible so that you can apply the repeated operations to other things, if that makes sense. All right, so there's a couple other things to note about for loops before we continue. So let's say this is going to be random list. I'm just going to make a list of like some numbers. Yeah, let's just do like one more. Okay, cool. So I've got 6 numbers in my list. Now there's 2 main ways that we can iterate through a list. The first one is going to be something like for num in random list, right? And then this will go, again, item by item through the list. But there's another way that we can also go through the list, which is for index in range len random list. So before I officially tell you the difference between these 2 loops, would someone mind telling me what they think the difference is between these two approaches and why we might want to use one of them over the other. Or I guess to step back a little bit, what am I doing in the second, more complicated loop that's different from in the first one?
Yeah, so that second one, you're basically grabbing the length of the list, so it's how many items are in it.
Mhm.
And then you're just going through each item, like going through the list that many times. Based on the index or like the range, or I'm sorry, like so
I mean,
print.
you were right the first time.
Yeah. I don't know what benefit it would have because I feel like it's doing the same thing, but yeah, that's basically you're just getting the length of the list and then doing it that many times.
Either if you need the element or the index.
Exactly, yeah. So both of you guys are exactly on the nose. So the first loop is going to be looping through each element or item in the list. But the bottom one is going to be looping through each index of the list. So, here, let's just, for this first one, I'm going to just print out num, which is our little iterable or iterator. And in the next one, I'm going to print out whatever IDX is. So if we run that, here we see that num is the element of the list, right? 12 and then 18 and 94 and 82 and etc. Versus, for IDX or our index, that's 0, 1, 2, 3, 4, and 5. So this list is six elements or 6 items long. So would somebody be able to tell me what the index is of 12 in that list? What's the index of that element?
0.
All right. And then what's the index of 54?
Length -1.
Okay. Or more accurately, that would be 5, right? So the difference between between these two is, as you can see, the first one just goes through it and gets you the elements directly. But the second one gets you the actual indices. And there's one critical reason why people will sometimes use the first one and sometimes use the second one. So let's say that my goal is to loop through the list. So let's say go through list and add 10 to each number in the list. So in the first loop, how would I modify the inside so that we're adding 10 to each number in the loop, or each number in the list?
Num plus equals 10.
All right, let's do that. Num plus equals 10. And then at the end, we're just going to print out our random list just to make sure that that works. So here, let's stop that, save it, and run it. Okay, so that's weird. It looks like it just printed out my original list. That doesn't make any sense. So let's print out random list before and after, like just to make sure. So say print before. Here I'm gonna just print like after. Oop, no, I want my code screen, please, not my desktop. And now everything is deciding to freeze. Wonderful. There we go. Okay, so, and I just also want to make sure that like this loop is running. So I'll just say looping. So let's see what happens. Okay, so before, and this is the list before, it runs through the loop 1, 2, 3, 4, 5, 6 times. So it's going through the whole thing. But after, this list and that list look identical. But aren't we changing num? Aren't we changing the thing at each index? Let's see. So let's try printing out num after we change it, or after we think we've changed it. And hey, look at that. So again, we have our before list up here, right? Then we have changed num every time. Because, I mean, look, 12 and 22 are not the same. 18 and 28 are not the same. 94 and 104, they're not the same. So num is changing, but the list overall at the end hasn't changed. And this is something really, really important. When you are looping through each element in a list, you cannot change the value of those elements. So note, looping element wise does not allow you to change the value of the elements you are looping over. And again, that's what we just saw, right? We went through this random list, we tried changing each element, but the list itself stayed exactly the same at the end. Any questions about that? Does what happened make sense?
Kind of, why is it immutable?
That's just the way that the list, or that the element wise list or loops work. They're just not. My understanding is that they run through a copy of the list essentially in memory for when they're iterating over it, and obviously that copy doesn't get updated as the list does.
So could you just update the list after or inside the loop to what the memory is storing?
Yeah,
Obviously, you could
and
push it to a new array, but
right. I mean, you could, but what you mentioned about updating the list physically itself is the way around it. And the way we can do that is here. Let's comment this line out, this line out. Let's just comment out that whole thing. And you know what? Here, let's copy paste this onto our index-based thing here. Okay, so let's try doing the exact same thing with our loop that we're looping through it index-wise. So again, just to remind you what that looks like, we're going through index 0, 1, 2, 3, 4, and 5. So in the previous one, we were just referring to num, like directly, like each number in this list. So let's do the exact same thing. I want to add 10 to each number in the list. But I only have an index. So our problem now has two parts, right? So we're going to need to get the number at index IDX, and we're going to need to write some code for that. And then set the thing at index IDX equal to itself plus 10. So let's do the first part. Let's see who I can call on. Jordan Anderson. How can I get the number that lives at index IDX in my list?
So would it be random list with the brackets and then IDX?
Perfect. Yep. So let's call that num. And let's set that equal to that. And then let's just print out num as well, just to make sure that we're doing everything right. We don't need to print out IDX. And yep, 12 is 12, 18 is 18, 94 is 94, 82 82. Okay, perfect. So it looks like that works. So we've gotten the number at index IDX. So now, how can we change the value of whatever lives inside of that index to be itself plus 10? Let's see, Dylan, any ideas?
Yeah, so if you wanted to keep your num variable, you could just do a random list at IDX equals num plus 10. Or I guess you could also do random list at IDX equals random list at IDX plus 10, but
Yep, we could do either of those. But I'm very glad that the one thing you did not say, which I'm glad you didn't say, is, oh, let's just do num plus equals 10. And that would not work. And the reason for that is when we say num plus equals 10, that's just updating this variable. it doesn't go back into the array and change anything. It just changes that variable. So if we want to change the values inside the array, exactly as Timothy said, we need to go into the array and tell it, hey, the value that lives at this address is going to be equal to the old value plus 10. So let's just make sure that this works. So I'll hit run. We see here before is 12, 18, blah, blah, blah. And then now we have 22. Hey, that's 10 additional. 28, that's 10. 104, that's 10 more, etc. So if you want to change the value of an element, if you want to change the value of element, yeah, let's say change the values of element. Values has an S. Use this type of loop, because the element-wise loop, while it's great and really simple, it will not do what we're looking for. It won't change the values. But if you go through it index-wise, you can change the values of elements. Any questions about that? I know it's a little confusing, and it might trip people up the first few times you do it, but this is something really important to know.
Does Python allow you to do like a for loop with the initialization condition and an increment, or is this just the way that Python works?
Yeah, this is the way that Python works. So in
Okay.
general, what Tim's referring to is like traditionally in outside of Python languages, like C is a good example. You'll have like for and then say like int I equals 0, I less than 4, I plus plus. And this is, again, different language syntax, but this is what you'd see in like C, Java, R, MATLAB. You see this sort of syntax where it's initializing a variable, it's setting a condition, and it's setting a step. This is identical to saying for I in range 0, 4, 1. So it's the exact same sort of setup where you're initializing a start, you've got some end condition, and you've got a step. But the only way to really do that is using the range function. There's not really anything else that I'm aware of for Python that lets you do something like that, if that makes sense. Any other questions about looping with for loops in Python, or more specifically about the difference between the element and index-based loops?
So is that the same thing if you're updating strings? If you have an array of strings or a list of strings, you need to index into.
So yeah, so if you have a list of strings, that's basically just like a list of lists. And if you want to be updating anything inside of a list as you go through it, you can't do that using element based. You always have to use the individual indices.
Are we going to be talking about enumerate today?
Yep, that was what I was getting to right after. So thank you, Dylan. The last type of for loop, which is important, is the enumerate loop, which it kind of combines both of these approaches. So here, let's do that. And here, let me also just do, let's say for, how do I want to write this out? So for enums, enumerates will give you two things in your loop. So so if you're looping over so enumerate of a list will return you a list of indices and then a list of the elements. So let's just see, let's print out the enumerate of random list just to see, what's in it. So as you can see here, it's going to give us a enumerate object. So helpful. So let's go ahead and let's break down that enumerate into two things. So we can say for index and then val, which I'm saying for value, in enumerate random list, let's print out IDX, and then let's also print out the associated value. So if we run that, here, let's do plus space and then plus value, and I should probably turn those into strings. String. There we go. So as you can see, so the IDX, the first part of enumerate, is literally just a list of indices, like 0 to 5. And the value, or the second part, is, well, the value that lives at that address. Let's say the element at every index. So enumerates are really helpful because, like I mentioned, they sort of combine the element-based and index-based loops that we saw above. So let's try doing the exact same thing. Let's say that I want to change the value at every single index and modify it by 10. Well, remember, val is the value at that index, and IDX is, well, the index. So what I should be able to do now is literally say random list living at, where did that go? Random list living at index. The thing in there is going to be its current value, value plus 10. So again, because we have the index and the value at the exact same time, it sort of like combines, the approach with the index loop, where first we have to get the element there and then set the thing living at that index, with the thing that doesn't work for an element-wise loop. And sort of combines them both and makes it a little bit easier. So again, we can just run this, make sure that it works. So let me just do that real quick down here. I'll hit run. As you can see, it goes through every single element and adds 10. And that's the main benefit of using an enumerate, is it can keep things a little simpler if you need it, in terms of, especially for those operations where you're trying to change the value of a list that you're working in. Enumerates are great, or, if you want to keep it a little simpler, element-based, index-based loops never really fail too much. Those are the main types of for loops in Python that we're going to talk about. Anyone have any questions about that? Nothing? No questions?
I have one.
Go for it.
Do you have to have the enumerate to do that?
Yeah, so in order to loop through both of these at the same time, you will need the enumerate. Otherwise, you can either go through only indices or only values.
Okay.
90% of the time, you'll see people just doing this element-based loop where it's just like the for, and then you just go through the list because it's simple, it's quick, and it's easy. The other 10% of the time, when people actually need to modify the list, they'll usually do the index-based loop. All an enumerate is a list of indices and a list of values. It's a lot simpler than most people think, but people still stay away from it because enumerates are apparently scary. I don't personally think so. I think they're nice and really helpful. But the majority of the time, people will use either this one or this one. But enumerates, like I said, they're great. They're really handy, especially for doing things with big data sets or modifying your lists. So it's a good thing that we're teaching it. Okay.
Would it be safe to just use enumerate for everything?
Yeah, I mean, you could.
Is there any issue with time complexity or anything?
Ooh. It might give you a bit of a problem with memory, because for an enumerate, I mean, it does create, essentially two separate lists. one list of indices and one list of values. So if you have like, a large data set, you might, but otherwise I can't think of any off the top of my head.
Okay, thank you.
Just a curiosity, earlier when I gave you that hexadecimal value, was that you were just printing enumerate and that's it? just curious why it printed it that way.
That is a really good question. So you'll see this a lot for things that are not basic objects. So let me back up a little bit. You guys will talk about classes pretty soon. I think that's either later this week or next. But essentially, think of like enumerate like a composite. So when you print out an object, like an enumerate object, that thing that lives somewhere in your computer's memory. And your memory is organized in hexadecimal, which is what that big string is. So Python doesn't have a nice format for printing out enumerates. So when you tell it, hey, I'm going to print out this object, it's like, this object is not a string. This object is not an integer. This object is not a list. I don't know how to print this. If Python doesn't know how to print something, it will print out the type of object that it is and where it lives. So that's why it says, hey, this is an enumerate object. It lives at this address in your memory. Usually that can be very helpful to do, especially if you want to make sure that something's, not taking up a ton of space, or it is where you want it to be, or that you're checking the type of object. But other times like this, it's just a little bit annoying because you realize, oh, there's no way to turn this into a string. Okay, well, it is what it is.
Can I add
Thank
one
you.
thing, Umar? I was gonna say for enumerate, there is like you can do this wouldn't be easier, but it's kind of like a lazier way, is if you are iterating through each element, if you try to think, I guess, what do you guys think enumerate does to provide the indexes for the list? Like how does enumerate figure out that it's going to count to from wherever to whatever?
I think it's just built in 0 to length of the array.
Right. So it has to know that it's counting to like a certain spot. But if we were going to try to mimic something like that going through each element of a list, what could we do, I guess? Well, if we initialized like an index or like a start to like 0 and then just did something like index plus equals 1, we would essentially have 0 to whatever the end of our list is. So you could write like a regular loop and do what enumerate is doing, but enumerate's a way to do that. So you don't have to write it like that.
I got you.
I don't, hopefully that's not confusing to anyone. I'm hoping that helps, but yeah, that's all I was going to say earlier.
Yeah, thanks, Phil. That explanation definitely helps clear things up. So I appreciate that. I need to charge my laptop so it doesn't die before the end of class. But yeah, so any other questions about for loops, enumerates, element-based versus index-based stuff before we very briefly move on to while loops? I know it's not on the topics list for today, but it's still pretty important. I think we should go over it.
That's the only thing that I have with enumerate is if you have a large data set that you're manipulating, is it mutable? Is it changing the original list, or is it creating a new one?
So it is changing the original list.
Okay.
Because you're changing it element by element. So because
And-
you're going through, sorry, it's changing it because you're referring to it by an individual index. So it's like going to the index of that list and changing whatever lives at that index.
And it accepts insertions and deletions as well.
Insertions, I believe so. Deletions are always a little bit complicated because that messes with the indices of the list. Yeah.
Okay, and my final question is, whenever you're, actually, I'll save that for later.
Okay, sounds good. Any other questions before we move on to the last little bit of Python, and then we'll do a little bit of JavaScript and you guys will be on your way. All right, awesome. So remember back at the beginning, we talked about the difference between for loops and while loops. So for loops will go through every single thing in something. It'll go through every single character in a string, every single element of a list, every single list inside a list of lists, you know, however you want to do it. A while loop, meanwhile, will run as long as a condition is true. So, for example, you could say, well, let's do that example where we had counting from 1 to 10 again. So what I could do is I could say, I is 1. So say while I is less than or equal to 10, I'm just going to print I, and then I plus equals 1. So what is this going to do? It starts out by initializing my variable I to 1. It'll then check, hey, is I less than or equal to 10? It is, so I'm going to enter into the loop. I'm going to print I, and then I'm going to make the value 1 more. So I becomes 2. And then it goes back. Is I still less than or equal to 10? Yep, it is. And so I'm going to print it, and then I'm going to make it 3. And we just keep doing that until, I becomes 10. Is 10 less than or equal to 10? It is. So we're going to print 10. We add 1, so 10 becomes 11. Is 11 less than or equal to 10? It is not. 11 is bigger than 10. So it exits the loop. So let's see an example of this in practice. While loops are a little more confusing. And as you'll see here, I forgot to stop all that. Let's take those out. Yeah, perfect. All right, let's do that again. So we'll see here, it starts out at 1, and then it goes all the way to 10, which is perfect. So nice, easy approach. You'll often see people using while loops for things like timeouts on a web page. You can use while loops if you can also use while loops to iterate over arrays, but it's a little bit messier. You'll often see people doing things with while true. Those are generally dangerous if you don't break out of them. So what we could do here is say like while true, let's say if I is less than 5, we'll do I plus equals 1, and then else we're going to break out of the loop. So before I run this, let me find a random person who I haven't heard from today. Let's see. Sandy, would you mind telling me your idea of what you think this code will do and why?
So it'll initialize while, since the condition is set to true, then it's gonna go to the if condition. And since I is less than 5 at the moment, it's set at 1, it will add 1 and print it. So it will say 1, 2, 3, 4. And then once it becomes 5, it gets out of that conditional statement, and then it will go to else, and then it will break out of the loop.
Perfect. Yep. So let's make sure that actually happens. If it doesn't, that will be bad because then we'll get stuck in an infinite loop and my computer will explode, which is a bad idea. So let's hit run. Oh, I guess I should probably have moved that print statement up to here and not, let's fix the indentation. There we go. But yeah, so it'll start out with 1. 1 is 1. It's while true. True is always true. So this is always going to run. If 1 is less than 5, yep, we print 1 and then we make 1 equal to 2. All right. True is still true. So if, 2 is less than 5, yep. So we go 3. True is still true. 3 is less than 5, yep, we'll make it 4. True is still true. 4 is less than 5, yep, we'll make it 5. True is still true. 5 is not less than 5. We go to the else statement, and break will automatically exit any loop, basically. So that's one way to print out the numbers. Now, I guess if you want to do 1 through 5, we could have done I less than or equal to 5. So let's just pretend like it was that way from the beginning. The other way that we can do it is we can set up a variable. So we could say something like less than or equal to 5 equals true. And we can say while less than or equal to 5. Now, and we can change this to our else statement can change from break to say, hey, this number is not less than or equal to 5 anymore. So we can set less than or equal to 5, that Boolean to be false. Now this functionally does the exact same thing, right? But except this time, instead of breaking out of the loop with our else statement, it'll just check, hey, is less than or equal to 5 equal to true? It's not. Okay, we're just not going to run the inside of the loop. And let's just run that to make sure this works. And we see here it goes all the way up to 5, and then it stops because it goes back to this while statement, and it says, oh, okay, guess I'm not doing this anymore. So we can just, just to check that, we can say entered into loop. And we'll see here that after it hits 5, let's see, print I plus equals 1. Yep, and then I'll go in here and then they'll stop. So that's the gist of how we use while loops in Python. These are used far, far less than for loops, but they are still used. Yeah, that's about it. Any questions about how while loops work?
I have a question, not exactly about how while loops work, but in this particular example that you just did, it sounds like it would be doing something pretty much exactly the same as if you have a for loop that goes from 1 to 5. It is a for loop only preferred because of its readability. In the background, it sounds like both of them are pretty much doing the same.
Yeah, for loops they just look a little bit nicer.
Okay.
It's usually easier to use them for that as well. But things like a while loop might be, let's say that, you're getting like a data stream from somewhere and you don't know how long this data stream is, but you know that you need to read the entire thing. So it's like you're reading a book that doesn't have an end, or that has an end, but you don't know when it ends. So you can't really use a for loop for that because the for loop, you don't know when to stop, but a for loop generally needs a stop. But for a while loop, I can just say, okay, while a page exists, turn to the next page, and just keep doing that until, oh, there's no more pages. Okay, let's stop. So that's like one sort of real world usage, you could say, for a while loop. But overall, if you're just trying to like go through something, for loops are the way to go. Like it's so much easier to read them. In my opinion, it's easier to use them. But while loops, for loops, you can make them do the same thing if you use them right.
Got it, thanks.
Any other questions? I know this stuff can be confusing, but it is really important. So feel free to ask as many questions as you guys need.
Will
I
you
got one.
will you go into an example where it's a use case where you could use both while and for loop at the same time?
Honestly, it's a little hard to think of one off the top of my head. So when we break for problems, I'll probably send one over. But in general, for loops and while loops are used for different things. But like again, for loops are good if you're like iterating over like you're doing something a defined number of times or you're going through an array. But a while loop is usually good like if you're waiting for something to change. Or yeah, that's what I would say. Like you're waiting for a condition to change. You need to keep doing the same thing until that changes. So it's like you can find ways to have a for loop do the same thing as a while loop, or the while loop do the same thing as a for loop. But in general, like 99% of the time, you won't really do that. But I'll see if I can find an example after.
Okay. No, you answered my question. Thank you.
Okay, sure. Does someone else have a question too?
Yeah, I got one just real quick. If you could you give me an idea of like when we would prefer using the second version of a while loop over the first one? Like what's the use case for that?
Good question. Hmm. I mean, they're both acceptable. I guess one of them is just slightly more acceptable to use than another. So, like for example, with this one, you're setting a variable from true to false. And that way, that changes the value of this variable. So if like later on, like I run through this loop, and I need to access the value of this variable later, I can just like print it or use it in some way. If you don't need to do that, then you're fine. Or similarly, for a condition, what you could do here, as well as you could say something like while I is less than or equal to 5, you could literally just do this and that. And that does the same thing. Yeah, without any variables. So at the end of the day, at least in my opinion, for while loops, most of the time it's going to be like stylistic. Shorter is better, especially when it comes to loops. So the most often used thing will be something like this, where it's like while, a really simple condition, and then you just do stuff inside the while loop. Sometimes you might see somebody do something like make the while like the statement inside a more complicated conditional. So be like while less than or equal to 5 and the sky is blue or something like that. And then whenever either of those changes, then that stops the while loop, hypothetically, stuff like that. So at the end of the day, for really simple stuff, it's stylistic. But if you have something that relies on a more complicated condition or reason to keep going, then you want to start playing with booleans. Does that make sense?
Yeah, I think I kind of have an idea. Like, so if we're going to use a while loop, right, and we're going to maybe use that or reference the state of that variable later on, it would make sense to use, that second version there, because then we're not just exiting the loop, we're keeping track of where that, loop ended with respect to that variable we set initially. So I think
Exactly.
that makes sense to me. So thank you.
Yeah, no problem. Again, while loops in general are a little bit more confusing, a little harder to use than for loops, so you don't see them as much, but they have their uses. We'll see them a bit as we go forward. But yeah. And also Philip sent a really helpful summary of the for versus while stuff in the chat. So I highly recommend checking that out. Because that is a really good summary. So thank you, Phil. Okay, I'm gonna just go ahead and check the lecture outline just to make sure that I'm not forgetting anything for Python. So here, we can go through that actually. So we have for loops, so we got looping through a list, like iterating through each element, iterating over the range, iterating over each index, iterating over the enumerate. Oh, yeah, we should also go over dictionaries. That's a good reminder. So here, let's comment out all of this stuff. And let's make a little detour and talk about dictionaries. So a dictionary at its core is the same thing as a key value pair. So if you think about it, like a normal list or an array just has like a bunch of stuff in sequence. But a dictionary is something that links not an index, but a key to a value. So, if I have an array, let's say blue. Nope, I don't need the console. That is weird. Let's say I have blue, potato, what's something on my desk? Pen, and brain. This is a list of 4 things. Now, we could write this list as a dictionary as well. I don't know why that keeps happening. But the list or the dictionary would look something like 0 and then blue, and then 1 and potato, and then 2 and pen, and then 3 and brain. So all of this is the only difference between these two is, well, this one's written as a dictionary, so it has curly brackets, and a dictionary explicitly says there's a key that maps to a value. The key 0 maps to the value blue. The key 1 matches to the value potato. The key 2 matches to the value pen, so on and so forth. But the difference between a list and a dictionary is our keys in a list always start at 0, 1, 2, blah, blah, blah. In a dictionary, our keys can be whatever you want. So we could say that like this is going to be like color. We could call this like a tater. Say not a pencil. I have this. So we can change up what our indices or our keys are in a dictionary. So we could call this, let's say like sample dict is going to be this thing. And let's just say like sample list is this. So one thing that you'll notice is the sample dict looks a little bit like that enumerate thing that we saw earlier. But let's see, I'm trying to think about what the easy way to do this would be. The difference between these two is, let's say I wanted to find potato in sample list. So we could print, sample list, and then potato is the second element, 2 minus 1 is 1, so it's at the first index. So we print sample list 1. And that should give us potato. But for sample dict, we use the exact same thing, but if you take a look here, it says index value, right? And we have 4 indices. These indices are not 0, 1, 2, and 3. These are color, tater, not a pencil, and I have this. So sample dict tater will give us the value. It's like plugging in the exact same thing. Like just like we plug in index 1 here, 0, 1 is potato. Plug in tater, and then sample dict, we start with color, and then tater, and then potato. So they both do pretty much the same thing. Now, when is a dictionary more useful than a list? So let's change this to be like person 1. So here, let's make a person. So we'll say like name, and we'll say Bob. We'll say age is 15. Food is gonna be pizza because Bob really likes pizza, as one should. Now, if we wanted to turn Bob into a list, we could do the same thing, right? We'd say this is going to be Bob 15 pizza. So let's say that at the same time, I have a second person. And I have a second person we're going to call Chuck. They are going to be a different number, 93. Okay. And their favorite food will be soup. So let's say that I have, let's add one more person, just to keep it simple. So I'll do person 3. We'll call Jane, 43, and their favorite food will be pasta. Okay, so we've got these 3 people, and let's make a list that contains all of these 3 people. So I'll say a list is going to be person 1, person 2, and person 3. And let's just print out that list. So let's save it and print it. And we see here we have this list that's got 3 people in, right? The first one is going to be Bob, the second is Chuck, and the third one is Jane. Now, let's say that I wanted to find out what each person's favorite food was in this list. Any ideas? How can I do that? So print each person's name with their favorite food.
I think I got to guess at it. You do maybe 2 for statements. You do like 4 person in people.
Okay.
And then you do 4 name, comma, food in person. And then you do print, name, food, however you want to do it.
Okay, let's try that and let's see what happens. So let's hit run. Ooh, value error.
Needs to be in curly braces. Is that right? The name and food inside the print statement needs to be in curly braces, and it needs to be I think it needs to be dot notation.
If you take a look here, it says the error is actually on line 95, which is in the for loop part. So, Charles, I think your instinct was right that we need to go through each person, but we actually don't need a second for loop. But we do need a way, though, like you said, to find out what the name and the food that each person likes are. So, let's think about this for a minute. Let's say that I wanted to find out what Jane's favorite food is. How could I write a statement that said what person 3's favorite food was?
Print person 3, brackets, food.
Yep, so person 3, and then food. And again, let's just double check that works. All right, forget that. Let's try that again. Perfect. And it prints out pasta. Forget the stuff at the bottom. But as we see here, food, pasta. Perfect. So what we need to do now in our loop, we just need to do the exact same thing, but for every single person. So remember that person in here is generic. It's person 1, person 2, person 3, person whoever. So hypothetically, what we could say is let's let name be the person's name, and then food be the person's favorite food. This should help us access the name and the food. And now we can combine that in a print statement with just like name, comma, food. And there we go. So again, iterating through a list of dictionaries by using for person and people. But remember, person is just one of these things. That's just a dictionary at its core. And the way that we get a value in a dictionary, like Jane or 43, is by referencing the key or the index. And that's how we get name, that's how we get food, and then we just combine them in a print statement down at the bottom. So this is, in general, the way that we're going to work with dictionaries in this course, and also going forward professionally as you use these constructs. You might ask when data structures like dictionaries are used. Honestly, you'll find that a lot of databases are structured with dictionaries in mind. So for example, if you have a database of people, you can break down each person in your database into, a name, an age, food, or a phone number, an address, a social security number, etc. All of those like rows on an Excel table, that can be turned into a dictionary pretty easily. So we won't get into that too much right now, but that is a very prominent use case for dictionaries that you will see in a couple weeks for the first time and going forward a lot more. So this is just meant to be like a real high level overview of what they are and how we can use them with lists. Any questions about what dictionaries are or how we loop over them? Okay. Any questions about any of the Python stuff? So that's the for loops, while loops, or dictionaries before really quickly we switch over to JavaScript for like 5 minutes, and then that should be all.
One question is, we use bracket to access here. I've seen it done where it was in curly braces, like person dot food.
Yep.
Is there a reason why we're doing it this way as opposed to bracket notation?
So
curly.
You've got the bracket notation and the dot notation for dictionaries. So the traditional way of doing stuff with dictionaries is by referencing the keys like you would in a list, like bracket and then the value, the key. The other way you can do it, which can be kind of fun, is we can no, not cute. You can say something like food is person dot food. And the dot here basically says that the dot is basically the exact same thing as brackets, and then food is, well, this thing in there. One of them just looks neater than the other. Like, come on, how much cooler is putting a dot and then stuff in lowercase without quotation marks than putting these ugly brackets? It just looks better stylistically, but again, this and that do the same thing. Only problem is if you have something in your dictionary that has a space in it, like let's say I said like fave food, you can't necessarily say person dot fave food in that way. So you would have to do that in here, inside of quotation marks like so. So in general, I like to use this method with the brackets and the quotation marks, just because it works for everything. It works for any key that you have. But if you want to have a little bit more flair and a little more style in your coding, you can use dot notation too. But they both do the same thing at the end of the day.
So follow up, if you do have spaces, is there like escape quotes that it accepts?
I believe so. I'm not too familiar with that specifically because I've never tried that. But I'm sure there's a way to do it.
Okay, thank you.
All right, so let's go ahead and move over to JavaScript. So we don't need the console log hello anymore. That's an old demo script. And let me just pull up my JavaScript notes real quick. Okay, cool. So JavaScript, we're not going to talk about while loops. We're only going to talk about for loops. So JavaScript has two main types of for loops. So there's the for of and for in loops. So let's see if we can do an example here. So let's create a sample array. So let's call this let sample array equal. Does anyone remember how to create an array in JavaScript? It's similar to in Python, but
Use brackets,
all right, which ones?
square brackets.
Perfect. Yep, so let's just say that this is going to be like Alice, Bob, Chuck, and Jerry. I'll put a semicolon at the end. Okay, so we've got a sample array here. You know, let's say I want to go through the array and print out everyone's names. So there's two ways that I can do this. Again, the first way is going to be using for of, and the second one is going to be using for in. So for the for of, we say for, and then we need to use let again. So it's similar to like for your blank in whatever you're iterating through. We can say for let, let's call it like name, and then of sample array. And then in here, we're just gonna like console log name, and that's about it. So yeah, what this should do is it'll go through sample array, it'll pull up every single person or every single, element inside of sample array, and ideally it should print it out. Also note that the variable inside of that loop is a temporary variable. So after you finish the loop, that thing doesn't exist anymore. It's basically gone. One thing to note here is that you cannot modify the value of an array using this for of notation. So I can't change the elements inside of sample array, unfortunately. But yeah, just to show you that this works, we'll hit enter here, and it prints out all four of our guys inside of the array. But it does not change. You cannot use this to change the array itself. So if you want an analog to this is basically the same thing as in Python, like just print it like doing this. They're identical, no difference. Let's see if I think I'm forgetting one more thing. Let's see, it's for of. Can't modify the array, which is really important. Oh yeah, for in as well. I forgot about that. So as you can see here, the for in loop is basically allows you to iterate over a dictionary. You don't see for in used very often. Oops. We don't see for in used very often at all. But people will, again, the main use case for it is for dictionaries. So here again, we got person, kind of similar to the person class that we made, or the person dictionary we made in Python. We'll say let key be in person. So the keys are first name, last name, and age. And we'll console log person at each key. So the first thing we'll do is let key be first name. Then we'll print out person, first name, John. And then it's going to move to last name, and then age, and so forth. That's really about it for loops in JavaScript. There's not a whole lot to talk about there. It's a little simpler than Python is. But Python gives you a lot more options and a lot more flexibility. So we talked about for of and for in. Talked about the 4 types of for loops in Python. Talked about dictionaries and loops in dictionaries. Yeah, that's about it for lecture content for tonight. Anybody have questions about any of the material before we end?
Yeah, in JavaScript, why would you use that if it's immutable instead of just a traditional for loop?
The same reason that you'd use it in Python. The syntax is just a little bit simpler and a little bit clearer.
Gotcha.
Especially, again, like most use cases, you won't need to iterate through, you won't need to change things in an array, but if you do, it won't work.
So if you're solving a problem and you use that, you're always going to be creating a new array to push to.
If you need to, yes.
Yeah, okay. Thank you.
Any other questions?